4 years ago, late in 2017, Turemetal introduced the UP7 Fanless Mini-ITX case. It was the second case that Turemetal introduced, following the smaller thin Mini-ITX UP2. The UP7 was marketed to cool 65 watts, either with Intel i3 or i5 CPUs. It generally only comes with an Intel LGA 1151 and 1200 CPU Heatpipe bracket, so you will have to contact Turemetal for an AMD AM4 or Intel LGA 1700 bracket if interested. Another unfortunate thing about this case, it's been discontinued, so there is very limited supply left and it won't be updated for more modern CPUs. The UP7 is made of aluminum, steel, and tempered glass panels, with a large heatsink on the right side of the case to cool the CPU. There is space for a graphics card up to 14.5 inches long, but there is no dedicated cooling for the GPU, and the tempered glass side panels don't allow for much airflow, so you'll want to stick with lower power graphics cards. The case is 15.5 inches deep, 10 inches wide, and 8 inches tall, about 20 liters, and weighs 11.4 pounds when empty. So it is barely what I would consider to be a small form factor PC, and it is quite similar in size to horizontal Mini-ITX cases like the Cooler Master Elite 130 or Fractal Design Core 500. It includes 3 8mm heat pipes to transfer heat from the CPU to the large heatsink panel. It is compatible with Mini-ITX motherboards, up to 4 2.5-inch SSDs, and standard ATX power supplies. One thing to be aware of when choosing a motherboard is that the heat pipes pass right above the CPU socket to the heatsink panel on the right, so the motherboard must not include a large VRM heatsink between the CPU socket and the top of the motherboard. The Turemetal UP7 is a very unique case that will work well for someone looking for a mid-range CPU and either no GPU or a low-end GPU, and wants a system with no or very little fan noise or dust issues. The UP7 is priced at $300 directly from Turemetal, including shipping from China. Although, as I mentioned before, the case has been discontinued and Turemetal just has a small number left. I will show you the build process and then stress the system to see how it holds up thermally. The system featured in this video will include the AMD Ryzen 5 5600X CPU, PNY Nvidia Quadro P2200 graphics card, Raijintek Morpheus 2 GPU cooler, ASRock B550 Phantom Gaming-ITX motherboard, 16GB of TeamGroup Vulcan Z DDR4 3600 MHz memory, a 500GB Samsung 980 Pro NVMe SSD, and a SeaSonic Prime Fanless PX450 power supply. The assembly of this system is fairly simple. The most difficult part of the build is getting the heat pipes properly aligned and fastened without making a mess with the thermal paste. I found it easiest to see how the heat pipes align first, before applying thermal paste, then setting the case on its side, heatsink down, to prevent the heat pipes from moving too much between thermal paste application and fastening the heat pipes in place. Now let's take a look at how the case performed thermally, with the help of Prime95, Furmark, and hardware info. First, I tested the CPU at 10 watt power limit intervals between 45 watts and 75 watts, so that I could build a trend line and estimate the power limit at which the CPU would thermally throttle when stressed for an extended period of time. The Ryzen 5 5600X throttles itself at 95 degrees, and using the trend line we get an X value or power limit of 79 watts when we set the Y value to be 95 degrees. The 5600X is a particularly difficult CPU to cool due to its small die surface area. So an Intel i5 CPU with a larger die will be a little easier to cool here per watt. As I showed in my previous video on how CPU power limits affect performance, the best performing LGA 1200 CPU at 80 watts is the i9-10900. The performance of the Rocket Lake CPUs is not far behind though, and for a better value I would recommend the i5-11400. With a manually set power limit between 80 watts and 100 watts, depending on your tolerance for high temperatures. With a compatible bracket though, an AMD Ryzen or Intel Alder Lake CPU could be a better fit. 80 watts of cooling is not bad for a $300 fanless case. For CPU cooling, it is competitive with the HDPlex H5 and Streacom FC10. Here's the downside though. The Nvidia Quadro P2200 with a fanless Raijintek Morpheus cooler began thermally throttling after 31 minutes of a Furmark stress test. I generally consider it a pass if the GPU can make it past 30 minutes of Furmark without throttling, so this is borderline acceptable in my opinion. The P2200 averaged about 60 watts, so I would expect a 75 watt GPU like the GTX 1650 to do even worse. The tempered glass panels with just a small opening on the corner of the UP7 doesn't really allow much air to escape from the GPU cooler. There is a lot of open area on the front and rear of the case, but without forced airflow it is not of much use. So unfortunately, the UP7 is not great for GPU cooling. Turemetal could replace the left glass side panel with an additional heatsink for the GPU, but of course that would add significant cost and assembly difficulty. I hate to say it, but as it is now, the UP7 is best suited for a semi-passive GPU rather than a fully passive GPU. The PCIe slot space might be even better suited for people that don't want a discrete GPU at all, and would prefer a different type of PCIe expansion card. My intention with this build was to directly compare the Turemetal UP7 with the SpyLabs Jack-of-all-trades, or JOAT. All of the components here, except for the power supply, are the same components used in a recent build with the SpyLabs case. The SpyLabs case had the addition of a Phanteks TC14PE CPU cooler with its fans removed for fanless CPU cooling. Comparing CPU cooling performance, the Turemetal UP7 was a consistent 5 to 7 degrees cooler than the Phanteks TC14PE. If the maximum allowable power limit for the UP7 is 79 watts, it is 74 watts for the Phanteks cooler in the SpyLabs case. Things are a bit different with the GPU, however. Even though with both cases I used the Raijintek Morpheus to passively cool the Quadro P22, the results were significantly different. When in the SpyLabs Jack-of-all-trades, the GPU was about 6 degrees cooler, and its temperature was clearly stable, whereas the GPU temperature in the UP7 was still slowly increasing after half an hour. The Raijintek GPU cooler is in a different orientation in these two cases, but before you assume that that explains the difference, take a look at this. These are some additional test results that I got when testing the Raijintek cooler with the P2200 in the SpyLabs case in 3 different orientations. In this graph, horizontal is the case in its standard orientation, with the GPU cooler in a standard flat orientation. Vertical is the case standing on its end with the length of the GPU cooler in a vertical orientation. Flat is the case lying flat with the width of the GPU cooler oriented vertically, as it is in the Turemetal UP7. So if we compare these two cases with their GPU coolers in the same orientation, the GPU is more than 10 degrees hotter in the UP7. This just goes to show how important adequate ventilation is for passive cooling. And with the UP7, it is not very good for the GPU. In conclusion, the Turemetal UP7 is a unique fanless heatsink case that offers great CPU cooling, but is not well suited for GPU cooling. It would be useful for someone looking for a mid-power CPU and either a very low-power graphics card or a different type of expansion card. Its size is average for a mini ITX case, and at $300, its price is competitive for a passive heatsink case that can cool 80 watts from a CPU. If you would like to get details and test results from every one of my fanless PC builds, and to help financially support this work, check out my Patreon page. Visit fullysilentpcs.com if you are interested in purchasing your own custom-built fanless PC. Thanks for watching. Like this video, share it, and subscribe for more fanless PC content.